Welcome to this new video tutorial. This is where we stopped in the last video where I was detecting my eye. We're going to see now when the eye is blinking. Actually, when both of the eyes are blinking. So when I do this movement, you can see in my eye that there is a vertical and horizontal line. The horizontal line stays always the same, doesn't matter if my eye is open or is closed, you can see, while the vertical line changes in size. If my eye is closed, the length is almost close to zero. When my eye is open, the length changes. That's the best approach to see when the eye is blinking. I'm going to check the ratio between these two lines, and we will have a solid approach in this way. That's the first thing that we are going to do right now. First, we're going to check the length of both lines, the length of the horizontal line and the length of the vertical line. And that's what we're going to do right now. To check the length of the lines, we need to know some basic geometry. And the formula to check the lines is the distance between, in this case, 2 points, is the square root of, it should be like something like this, square root of x2, the x of the second point minus x of the first point, elevated to the power of 2, which I don't know how to do in this case. Let's put it this way, and then y2 minus minus y1, and that's the distance. But anyway, we're going to use some library that will make this much easier. We are going to import, actually from math, import HiPot. So we have first the length, vertical line length is equals to HiPot, and we're going to pass the x, first the x of both the objects and then the eye. So we take as vertical line, we take first the x of the center top and the x of the center bottom. So we take center top 0 minus center bottom 0, and then center top 1 minus center bottom 1. Top 1 minus center bottom 1, and I should open the parentheses here, and let's print the length, print vertical line length, and let's see what we get if everything is correct. And here is the length. Let's see, if I go further it should be smaller, so we get smaller number. If I go closer to the screen, we see that the length is much bigger, so this should be okay. Let's use the same approach for the length of the horizontal line. Horizontal line is equals to CV2, no, or horizontal line length is equals to HiPot. In this case, we should take left point and right point, x and y, as we did before. Left point 0 minus right point 0 index. Let's close them inside parentheses, and then left point 1 minus right point 1, and now we have the length of the horizontal line. Okay, yeah. Once we have this, we can divide the horizontal line with the vertical line. So let's divide print horizontal line divided by vertical line. Oh, the length, I forgot. Horizontal line length. And let's see what we get. Around 2 point something. I close my eye and the value changes. You can see the ratio changes. When my eye is open, it's around 4, 3, 4, 5. When my eye is closed, I cannot see, but it's above 6, I guess. I have my eye closed, I cannot see what's going on in the printing, but I guess it's above 6. We can detect the blinking in this way. We have the ratio. Ratio is equals to horizontal line length divided by the vertical line length. If the ratio is, let's say, greater than 6, then we can say that the eye is closed. So instead of printing it on the screen, let's for example put some text. cv2.put text. We're going to put the text on the frame. The text will be blinking. The position, let's say 50 on the x-axis and when 150. The font, the scale 2 or 3, let's say 3, and the color, let's make it blue. BGR, so 255 of blue, 0 green and 0 red. We need to define the font. Let's do this before the while loop. Here, font is equal to cv2 font, and let's take one here. We'll take the first one, font Hershey simplex, and that should be enough. And let's run the script and let's see how it works. It's we can see blinking in some moment. It's working, not always. Probably we need to change a bit the ratio. So probably my eye is blinking when the ratio is 5 something, 5.7 for example. Now it's a really solid approach. You can see now that it's working fine. Let's change some font that maybe we can see better. Font Hershey, plain. Let's see this font, maybe it's more clear. I like more this font. We change the size to 7. It's not necessary that you change the font even because we're not going to use it later anyway. Okay, we somehow detected when the eye is blinking. Of course, there is some improvement to do and we will do that later. But first, we're going now to do the same approach also on the second eye, because when we detect the blinking of both eyes, our detection will be more accurate. So let's now improve a bit the function. We want to get the ratio. Now what we have for the left eye, we want to detect the ratio for both of eyes. We have to do something similar, actually the same, but for the other eyes, so just the points are going to be different. If the first eye had the point from 36 to 41, the second eye will be the same approach, but from point 42 to 47. We can use the same, but let's put this in a function. So starting from left point, let's copy everything till ratio. I'm going to copy this one, copy, delete it from here, and let's create a function. Let's call it let's say blinking ratio, blinking ratio, and let's put all the values here. Instead of giving the numbers, we're going to pass the number inside the function later on. So we can call this the points. We'll pass the points first for the first eye and then for the second eye. And there is something else that we need to give to this function, I guess. And also, okay, we need to pass also the facial landmarks. The function will take the position of the points and which point we are going to work on. So points and facial landmarks, let's put it this way, facial landmarks, and eye points, it will be more clear. And let's change these landmarks with facial landmarks, not to confuse it with this one. Facial landmarks. And then eye points. The 36 is the first one, so we're going to use index 0. 37 is the second one, so it will be index 1, and the same approach is for the second eye. 42 is the first one, 43 is the second. So it's going to be really easy. Eye points 36 will be the first one. Same here. 0. 39 will be 1, 2, 3, index 3. Same here, index 3, 37, index 1, 38, index 2, 41, index 5 is the last one, and 40, index 4. And this function is going to return the ratio. Return ratio. After landmarks, where we have all the exact positions of the point in the face, we can call the function. And the function will return the blinking ratio of the specific eye. Let's see. Let's now work with the left eye. Left eye ratio is equals to get blinking ratio. We need to define the points of the eye, and so we're going to use from 36 to 41 the points of the left eye, 36, 37, 38, 39, 40 and 41, and then the landmarks. And let's say if left eye ratio is greater than 5.7, and we'll put the text eye blinking. Everything is exactly as it was before, and for some reason my webcam is not starting. Let's try again. Okay, now it's running just a couple of seconds. The function is it's working as before, just the difference is that we have a function that we can use. Now we will use the same approach for the right eye. Left eye ratio, and we will have right eye ratio equals to get blinking ratio, and then let's pass the numbers for the second eye from 42 to 47. 42, 43, 44, 45, 46, 47, and then the landmarks. If right eye ratio is greater than 5.7, then we can detect that the eye is blinking. Index out of range. Oh, 478. I didn't see this one. And again, my webcam doesn't want to start. I don't know what's wrong with my webcam. You can see now we have the ratio, the blinking detection for both of the eyes. One last improvement to end this video, and then we can stop the video. Now we are taking the ratio only for the right eye. As you can see, if right eye ratio is greater than 5.7, as we are detecting both eyes, let's take the ratio for both the eyes, then we find the average between them, and then we calculate if the eye is blinking. So we will have average, let's call it blinking ratio is equals to left eye ratio plus right eye ratio, and then divided by 2, both of them. So if with one eye detection is not working properly, there is the second eye that will change, let's say improve the ratio, because it's the average, so both of them must be close to work properly. And let's see if, let's just try to close only one doesn't work, both of them it will work. Now the blinking is quite fast. We should improve this function later on to detect only like longer blinking like I'm doing right now. And also we will try to detect the direction of the eyes. See you then in the following tutorial.